Hi, this video is meant to teach you the difference between chemical properties and physical properties and chemical changes and physical changes. This is going to be a really important thing to know about in chemistry this year because we're going to be looking at properties every time we do a lab. We're going to be writing down those observations. And chemical changes are chemical reactions. They're the really important things that we're going to learn about this year when we do chemistry. And so it's going to be important to know that in a physical change, we're not changing the substance, but in a chemical change, we are. We're making something new. All right. First of all, physical properties. You need to write down this list. It's really important that you know these examples. It's important you know these bolded, underlined vocabulary words because these are the things we're going to write down about observations. Chemical properties are a little different. Chemical properties are also things we can write down. They're observations we can write. But in a chemical property, we can only figure it out if we change the substance. To find out if something lights on fire, you got to light it on fire. That's flammability. Versus a physical property, you kind of just look at it. I mean, you don't change something by looking at it or just putting it on a scale. So that's a physical property. All right. So what we're going to do is we're going to look at an example now. So this is pretty cool. These are some water balloons that are filled with air, and an orange peel is squeezed over it. And what happens is the balloon pops. That's kind of amazing, right? I want to do this. So the deal is that if we're going to write down observations from this, we're writing down properties. Oh, I see three different colors. I see red and orange and blue. I see the orange peel is being squeezed. I see that there's a gas inside the balloon because when it explodes, it gets much smaller. Um, those are all really important physical properties. I'm seeing them just by looking with my eyes. All right, what's interesting is chemical property. Is the ability of the balloon to explode a chemical property? Well, not really, because the material itself is still the same before and after. Anybody who's blown up a water balloon and thrown it knows the rubber stays behind, right? You got to go pick it up afterwards. It doesn't just disappear. So the material is the same before and after, even though its appearance is different. So in other words, we're not measuring any physical property, any chemical properties here. We're not measuring chemical properties, but we are measuring physical properties. By the way, you can use your nose to smell the nice lemon orange peel smell, which, by the way, is actually a big tip off for why this happens. You might want to look it up. All right, so a physical change like popping a balloon is something that changes the appearance of a material, but not what it's actually made of. The rubber is still there. You should write down this list of examples. In a physical change, the spacing between the particles changes, not the particles themselves. This is different from a chemical change, which changes the bonding in the particles. So in other words, it changes the particles. They're new particles. Reactants, by the way, is the vocabulary word for the beginning substances, and products is the vocabulary word for the ending substances. All right, so we got a bunch of examples here. Melting, chopping, shredding, mixing, it's all the same stuff before and after. It's made of the same material. Whereas burning is different now. It can't be burned again. Rotting bananas, it's not made of the same material before and after. The fungus ate the stuff and pooped it out, or the bacteria ate the stuff and pooped it out, or the flies ate the stuff and pooped it out. It's different. All right. So it's important to realize that reactions, chemical reactions, which is chemical changes, another name for chemical changes, can be written in the form of equations. Remember, we don't just look at the macroscopic with our eyes. We don't look at just the particles. We also look at how we represent this in symbols or formulas. And so in the later example at the right, the liquid butane, which is bonded like this, goes up through the lighter and comes out, and there's a flame, and it turns into carbon dioxide and water. That's why butane and oxygen are the reactants. Wait, oxygen? Yeah, because you need oxygen to burn things. It's coming from the air. It's not displayed, but the oxygen comes in that way. And then carbon dioxide and water are the products, so we'll write them on the right side of an arrow. So that's called the chemical equation. All right, so this is a little different from a physical change. If you just hold down the lighter like this and you don't click the little sparker, then what happens is that the liquid butane turns into gaseous butane, and it doesn't light on fire, and it's still butane. Well, it could light on fire later, so be careful you don't light a match somewhere else. On the other hand, if you light the fire here, it turns into a new substance. All right, so here's another example. you should write down the similarities and differences between these two pictures, as many as you can figure out, as many similarities and differences as you can. So on the left is a picture of a hot spring, and on the right is a picture of a match. So try that out. All right. First obvious thing, they're both hot, right? So there's a difference though. The hot spring, the heat's coming from underneath, from the outside, which makes it an endothermic process. Whereas in the match, the heat's coming from inside the wood. The match is not just a result, it doesn't just release the heat from that initial spark, it makes its own heat for a long time. So this is an exothermic process. The chemical reaction makes the heat. Another similarity, they both make gases. So this is a gas, this is gas. Interestingly, they both make water. There's both making water vapor. So just like the butane makes water vapor when it burns, wood makes water when it burns, and carbon dioxide. All right, the difference is there was liquid water at the beginning and there's liquid water at the end here, versus there's no liquid water in this match, but there is gaseous water in the flame. All right, you also might want to point out there's color differences, there's the flame difference, there's might be a couple other similarities that you came up with, but those are the major ones. All right, so if we could see the particles or the reaction equations, we could tell the difference between a chemical change and a physical change really easily. But if we have to use our eyes in the lab, it's a lot harder. Key thing to point out is that never call something a chemical change unless you have more than one piece of evidence that this is a chemical change. Remember, chemical changes are changes in substance. So always go back to thinking about, is the substance itself actually changing, or is just the appearance of the substance changing, like if it was boiling? First of all, is heat given off or absorbed by the substance itself? The match, remember, gave off heat from within the wood, but the hot spring, the heat was from outside. So if the heat's given off from within the substance or taken in the substance, that might be a chemical change. Changes in color. The hot spring, it looked like blue water and white steam, but it isn't a chemical change. The match, it's much more obvious that there is a change in color. Or a change in odor. Matches have that burning smell. Not easily reversible. It's really hard to unreverse burning or to reverse burning. It's kind of easy to reverse boiling. You just cool off the steam and now you got liquid again. All right. Did it make a gas? Well, both of them are making gases, but you had to heat the one at the left to make the gas, whereas the one on the right is literally the wood falling apart that's making the gas. Producing a solid also is another idea that if, like, for instance, think of the example of baking a cake. If you heat up the liquid batter, it turns into a solid cake. Well, think about that. That doesn't seem to make sense, right? If you heat something up, it turns into a solid. That's not a phase change. That's not a physical change. It's a chemical change. Versus making a gas, if you cool something off and a gas is made, that's also probably a chemical change, not a physical change. And finally, change of properties. If you burn something, you can't reburn it. So flammability, if it changes its flammability, it's probably a chemical process, not a physical process. All right, we're going to look at one last set of examples. So here we can see the particles. In the phase change, we have liquid water at the beginning, we have liquid water at the end. It just changes the spacing between the particles. Whereas when you rust a nail, you have iron atoms at the beginning, you have them at the end, but now they're bonded to oxygen from the air. And look at that nice color change. Rusting is pretty irreversible. There's going to be multiple pieces of evidence here that this is actually a result of a chemical change, not a physical change. So to recap, we learned that chemical changes change the substance, physical changes don't. They just change the appearance. We learned that chemical properties, you have to change the substance to measure them, whereas physical properties, you don't. It's just the same substance at the end.